Hello folks, and welcome back to another lesson here. Today we're going to be talking about section 6.8. This is going to be all about graphing radical functions. Or in other words, what we're going to be doing today is we're going to be graphing square roots and cube roots and such. Now before we get into that, let's remind ourselves of how we can adjust our functions, how we can adjust the graphs and their transformations. We have here y is equal to a absolute value of x plus b plus c. See if you can remember what each of these does. What does a do, what does b do, and what does c do? So the coefficient here, or the a value, is going to be our vertical stretch or compression, meaning that it's going to tell us how much taller or how much shorter our function is. It also tells us whether our function opens up or opens down, whether it's flipped or whether it opens regularly. If it's positive, we open up. If it's negative, we open down. Now our b value, the value inside of our absolute value, the one closest to x, this moves us horizontally. So translate, just the fancy way of saying moves, horizontally. And then c moves us vertically, or it moves us up and down. The value closer to x moves us left to right. Now, let's go ahead and try to graph y is equal to the square root of x and see what it comes up with. We're going to do this using the table of value methods. So let's pick out some values that we might want to use to substitute in for our graph. So let's go ahead and pick some values for our table of values. Let's try -1. Let's go with 0. And now because we know we have to take the square root, let's make sure we're choosing our values that make sense. We know we can take the square root of 1. We can take the square root of 4, and we can take the square root of 9. Okay, let's figure out what our y values are. The square root of -1 is undefined. The square root of 0 is going to be 0. The square root of 1 is going to be 1. Right, we're just dealing with the positive values, not the negative ones. Square root of 4 is 2. Square root of 9 is 3. Meaning we can graph these points out. We have nothing at -1. At 0, we're at 0. At 1, we're at 1. At 4, 1, 2, 3, 4, we go up to 2. And at 9, we go up to 3. So our graph just sort of abruptly starts at 0, and then it goes up in a little bit of a curve. Remember this function or this set of values when we're trying to graph. From your starting point, you go over 1, up 1, right? We take the square root. We could go over 4, up 2. We could go over 9, up 3. Now, for a square root function, our transformations act very much the same way as before. If we have y is equal to a square root of x plus b plus c, a is still going to move us or stretch us vertically, b is going to move us up or down, and c is going to move us up or down. B is going to move us left or right. So let's go ahead and try to graph some of these. We have our function here, y is equal to 3 square root of x plus 2 plus 1. Let's figure out what each of these does. The 3 is going to stretch us by 3, meaning that each of the changes we have to y will be tripled. If we're thinking about this, our original function would go from 0 to 1, 1. So now we're going to go from 0 to 1, 3. We'd go from 4, we'd go up 2. This time we're going to go up 6. So our function with the stretch would go 0, 0, 1, 3, 1, 2, 3, 4, and up 6. 1, 2, 3, 4, 5, 6. This is what the parent function would look like with that little stretch. But we have to remember our 2 and our 1. The 2, remember, we flip which way we move horizontally. So this moves us left 2, and the plus 1 moves us up 1. Meaning that we're going to move left 2 and up 1. And we're going to start from that point and use our red graph as a reference. So instead of going up 1, 1, we went up 1, 3. So we're going to go over 1 and up 1, 2, 3. Instead of going over 2 and 4, we went up 2 over 4, or up 2, 4 over 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And our graph would look like this. So we've tripled the amount we change y. We've moved left 2. We've moved up 1. For the second one, we have this negative here. So we're going to be opening down, or we're going to be flipping which way our y values go. And we have this negative 3. So the negative 3 tells us we're going to move right 2. Remember, our horizontal changes get flipped. Right 3, excuse me. So we're going to start by moving over 1, 2, 3. And then if we need, we can graph our parent function. Remember what that looks like. Up 1 over 1, up 4, or over 4, up 2. And now we're just going to reverse these. So we're going to go from our starting point over 1, down 1, and over 4, down 2. 1, 2, 3, 4, down 2. So we're graphing in red our parent functions. Then remembering we're going to flip it, we're going to reverse it if we have a negative, and we're going to shift our starting point. So that's what these two graphs look like. Now it's your turn. We're going to have you try a couple. Specifically, I want you to tell me what the transformations are, and then try to graph them. So for starters, what transformations do we have in the square root of x minus 5 plus 2? And then try to graph it. For x minus 5 plus 2, we're going to be moving right 5. Because we flip our horizontals, we're going to move up 2. So we're going to move up right 1, 2, 3, 4, 5, up 2. Then we're going to start our basic graph. We're going to go over 1, up 1, just like the square root of 1 gets us up 1. Square root of 4 is 2, so we're going to move over 1, 2, 3, 4, move up 2. And that would be our graph. What about negative 2 square root of x plus 3? What transformations do we have? And how would we graph that? For this, we have a negative 2, so we're both going to flip and stretch by 2. Or in other words, we're going to double the amount we change y. Anytime we'd move up 1 in y, we'd now move down 2 in y. If we were to move up 2 in y, we'd move down 4. We're also going to move up 3 because of our plus 3. So we're going to start at 0, 3, 0, 1, 2, 3, and then we're going to start. So we'd normally go over 1, up 1. We're going to go over 1 and down 2. Normally, the square root of 4 is 2, so we'd go over 4 and up 2. We're going to go over 4 and then multiply that by negative 2 to go down 4. 1, 2, 3, 4. Normally, the square root of 9 is 3, so we'd go over 9 up 3, but we have to multiply our change in y by negative 2. So we're going to go over 9 and down 6. So go over 9 and down 1, 2, 3, 4, 5, 6. And this is our function. Let's do one more of these, two more of these. What about y is equal to 1/2 square root of x minus 5? What are our transformations and what will the graph look like? For this one, 1/2 means we're going to compress by 1/2. Or in other words, anytime we're supposed to go up 1 in y, we're going to go up 1/2. We're just going to half all of our change in y. We're also going to move down 5 because of our negative 5. So we're going to start at 0, negative 5, 0, 1, 2, 3, 4, 5. Now normally we'd go over 1, up 1. Square root of 1 is 1. But this time we're going to have to multiply that by 1/2. So we're going to go over 1, up 1/2. We'd go over 4 and up 2, but we have to half our change in y. So that'll bring us to 1/2, or 1. We'd go over 9 up 3, but we have to half that again, so we're going to go 2 up 1.5. And there's our graph. Finally, this last one's a little bit confusing because we first need to simplify it. We first need to see if we can get this into parent function form. How do we do that? Well, we have two terms here which both have a 9 in it. We could factor this to read the square root of 9 times x plus 2. From here, we could take the square root of 9. Square root of 9 is going to be 3, and then we're left with our x plus 2 on the inside. So that might show up where you have to factor out some value and take the square root. So the square root of 9x plus 18 is the same thing as 3 square root of x plus 2. What are our transformations? And try to graph this graph. Our transformations are a stretch of 3, so we triple any y change, and we move left 2. So we're going to go over, start at negative 2, 0. Normally we'd go over 1, up 1. Square root of 1 is 1, but we're going to triple that. We'd go over 4, 2. We're going to triple that, so we're going to go over 4, up 6. 1, 2, 3, 4, up 3, 4, 5, 6. We'd go over 9 and up 3, but we're going to triple that. So we're going to go over 9 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. And there is our graph of the square root of 9x plus 18, or 3 square root of x plus 2. And that is the basics of square roots. Now we're going to look at one more thing, which is a cubed root. The way a cubed root works is we're going to start with the graph of a cube, and then we're going to flip everything. A cube root and a cube are very similar. We'll just have to flip our x and y values. They are inverses. So when we're dealing with the cubed root, let's try out some values. If we put in negative 2, negative 1, 0, 1, and 2 for x, what are our y values going to be? For the cubed root, or for a cube, negative 2 cubed is going to get us negative 8. Negative 1 cubed is going to get us negative 1. 0 cubed will be 1. 1 cubed will be 1. And 2 cubed will be 8. So these are the values for our cube. Let's make a graph of our cubic function. Start at 0. We go over 1, up 1. We go over 2, up 8. We go left 1, down 1. We go left 2, down 8. This is our graph of a cubic function. Now all we're going to do to get the cubed root, because these are inverses, is flip x and y. So for y is equal to the cubed root of x, we're just going to flip our x and y values from this table. So instead of it being negative 2, negative 8, we flip x and y, it becomes negative 8, negative 2. Instead of having negative 1, negative 1, we're going to have still negative 1, negative 1. 0 and 0 get swapped, so our x and y values get swapped. 1 and 1 get swapped. And 2 and 8 becomes 8 and 2. So we've just flipped our x and our y values. This is our values for the cubic function here. So let's start. We're at 0, 0. We go over 1, up 1. We have the point 8, 2. So we're going to go over 8, up 2. And then we're going to do the same thing in reverse. So we have negative 1, negative 1. We're going to go down 1, over 1. Then we have negative 8, negative 2. So let's plot that point. This is our graph of a cubic function. Notice how it just looks like the cubed function, just flipped on its side. These are the values we're going to use for transformations. So we have this little table of values, negative 8, negative 2, negative 1, and so on. We're going to transform those if we have to stretch, and we're going to move this function. So let's see an example of this. Now we have 2 cubed root of x plus 1 plus 4. What do we know about this function? The 2 tells us we're stretching by 2. The 1 tells us we're moving left 1. And the 4 tells us we're moving up 4. So let's start by graphing our parent function, that way we can adjust it. Our parent function, we start at 0. We go over 1, up 1. We go over 8, up 2. And then from our starting point, 0, 0, we go down 1, over 1. And from our starting point, we go over 8, down 2. I always like to start from 0, 0 because it gives me a good reference point for drawing the rest of our points. So this is the set of points from our parent function. Now we need to move our starting point, our 0, 0 point, up 4 and left 1. So let's move left 1 up 1, 2, 3, 4. And now this whole graph is going to get stretched by 2, or all of our values are going to get doubled. So when we do this, we're going to move over 1, we're going to move up 2 now. From this starting point here, right, we have our 2 starting points. We're going to move over 8, and it looks like we went up 2, so we're going to double that. We're going to go up 4. 1, 2, 3, 4, 5, 6, 7, 8, and up 2, 4. Same thing going the other way from our starting point. We're supposed to go over 1 and down 1, but we're going to double that change. So we're going to go over 1, down 2. And from our starting point, we went over 8 and down 2. We're going to do the same except for double it. So we're going to go over 8 and down 4. 1, 2, 3, 4. So our function here is going to look like this. I know the graphing part of this is a little confusing. The important part is to make sure we understand the transformations and we can try to graph it based off of our parent function. To this, we're going to have you try to identify what all of our changes are for this function, and then we'll go through graphing it together. What are the values, or what are our transformations? Well, for starters, we're going to flip because we have the negative. We're going to compress by 1/8. We're going to move right 3, and we're going to move down 1. Now let's start with our parent function before we start to try to apply these. Our parent function starts at 0, 0. We have the point 1, 1. We have the point 8, 2. Oop, that's 8, 3. And we have the points -1, -1, and -8, -2. If you ever forget your points, just try to take the cubed root of a couple of points to figure it out. What's the cubed root of 1? It's 1. Cubed root of 2, 3, 4, 5, 6, we don't know. But the cubed root of 8 is just 2. So we can figure this one out pretty simply. And let's make these points red. That way we know it's our parent function. Now the next thing we're going to do is we're going to move our starting point, our 0, 0 point, right 3, 1, 2, 3, and down 1. Then from here, all of our changes in y are going to get inverted and compressed by 1/8. Or in other words, each of our changes in y, we're going to multiply by -1/8. So for example, we moved to the right 1 and up 1. We moved up 1, so multiply that by -1/8. We're going to move down -1/8. So we're going to move right 1 and down 1/8. Then if we moved over 8 and up 2, so 8, 2. We're going to change that so that we move over 8 and down by 2 times -1/8, or -1/4. So we go 1, 2, 3, 4, 5, 6, 7, 8. Our points all the way out here, and we go down to 1/4. The opposite way, we moved left 1 and down 1. So the down 1, we multiply by -1/8. We go up 1/8. Then this last point over here, we moved over 8, left 8, and down 2. So negative 2 times 1/8 will get us positive 1/4, meaning we're going to move over 8 and up 1/4. So we move 1, 2, 3, 4, 5, 6, 7, 8, and up 1/4. And what we end up getting is a very compressed graph that looks like this. Now the graphing of cube roots is definitely difficult, but we need to make sure that we understand all of our transformations, and we'll be working with the graphing a little bit more in the future. Anyways, folks, that's all there is for this lesson. Go ahead and get started on your homework.